Welcome back. Today I'm going to be going over this volume question that frequently comes up actually on the SAT. Um, and there's a very specific fact that you need to know in order to make this question 10 times easier for you to solve, right? But once again, thanks to Aniko.ai for providing this specific question in their free resources tab. And before I get started on the explanation, please give it a try yourself. Okay, so before we get started, right? Let's first talk about specific that fact you should know, right? So this question here has to do with finding the volume of a cone, right? Now, what you'll actually realize is there's a ratio in this problem, right? But again, we'll get to that later, right? First thing you should know is that you have three different entities here, right? You have volume, you have lateral surface area, right? I'm just gonna abbreviate as SA, and then you have the linear, right? Or like I'm gonna call that the sides, right? So what am I doing? What is all this for? Well, let's say that the ratio of two similar cones, right, or really two similar um, figures, right, in general, right? Let's say that ratio is A to B, right? So once again, I'm just gonna draw a cone because we have a cone in this problem, but this can work for any, right? Right? If you have a cone here and then you have a similar cone, right, to scale up, right? Let's say that the ratios of the sides of the cone, which doesn't make sense in this case, right? Um, but let's say the ratio of the sides were A over B, right? And I guess you could think of the side as, well, just think of it as a circumference for a second, right? Think of that as A over B. So now, if that's the predefined ratio for the sides, right? The ratio for the surface area is A over B squared, right? And likewise, the ratio for the volume, right, is A over B cubed. You might be wondering, well, why is surface area squared? Why is volume cubed? Why is it this specific ratio? Um, you don't really need to know that for the SAT, but the most basic answer to that question is that it has to do with the dimensions being involved. So in this case, right, volume is a three-dimensional, right? It's a three-dimensional concept, right? Lateral surface area is a two-dimensional concept. Sides, right, just in general, right, if you look at one side of a figure, that's a one-dimensional concept. So that's where the cubed, the squared, and then the base factor itself actually comes from, right? Again, that's the most simple definition, um, but now this is the important fact, right? This makes our problem easier because now we're given that cones A and B, right circular cones A and B, are similar. The ratio of the surface areas of cone A to cone B is 25 over 9. And if the volume of cone A is 500 pi, right, which choice is the volume of cone B? Cone B. Well, this becomes really easy now, right? Is because we know the ratio of the lateral surface area is 25 over 9, right? So the surface area of A over the surface area of B, what we're given, that's 25 over 9, right? And if we're trying to find the volume, right, we need some sort of way to get A over B cubed, right? Well, to get this specific ratio cubed, we have to first find the basic side uh, ratio, right? The basic linear ratio. To do that, well, surface area is just that ratio squared, right? So you can say this is equal to A over b squared, right? Once again, that's this specific part, right? And what that allows us to do is find a over b, right? Because you take the square root. So if you take the square root of both sides here, right, you get that a over b equals 5 over 3. So that's our linear, right? This is our linear, and I'm just going to kind of label this as our surface area. How do you find the volume? Well, our volume is just that factor cubed, right? So it's going to be 5 over 3, right? The linear side factor cubed. And what that gives us is the ratio of the volumes, right? So this is going to simplify to 125 over 27. And we know that the volume of cone A is 500 pi, right? So once again, this is the ratio of the volume of A to the volume of B, which is equal to 500 pi over the volume of B, right? That's what we're trying to find. So, right, we have basically this that we can cross multiply and this that we can cross multiply, right? So we have 125x equals 27 times 500 pi, right? And what I'm actually going to do here is, instead of saying x, I'm actually going to say 125 x pi, right, equals 27 times 500 pi. The reason is because all the units you see here are in pi, right? Or like these are all in terms of pi, right? So as a result, right, you would use pi here. So, and that actually makes it easier, right? Because now you can just cancel these pi's out, and you're left with x equals 27 times 500 over 125, which will give you a nice number, right? There's no decimal going to be involved. That gives us 108 as our answer. And of course, that's what I circled here, right? 108 pi. So once again, the key thing for this problem is to know that the sides have a ratio of a over b, right, between two similar figures, right, between two similar 3D figures. The surface areas have a ratio of a over b squared, and then the volumes have a ratio of a over b cubed, right? And that'll allow you to find that missing volume, right? So once again, I hope you understood that specific fact. If you have any questions, leave it down in the comments. Please hit that like button, click on the subscribe, and we post videos daily to help you guys with ACT and SAT prep. So if you want to be notified, also hit that notification bell, right? But that's it for this video, right? I hope you really enjoyed, and I'll see you next time.